Good evening, everyone. Thank you, delegates and panelists, for joining this session on that. My name is Mahesh Kalai, Associate Editor, B2B Purchase Magazine, and I welcome all of you to the live fulfillment series on the wonders of mega infra. Over the past few years, this ancient and diverse nation has embarked on the ambitious mission to revolutionize its core foundation. From the state-of-art transportation network that crisscross the country to the futuristic smart cities shaping the urban landscape. On that note, this live interaction by B2B Purchase Magazine on the wonders of mega infrastructure will explore the inspiring feats of engineering, innovation, and yielding determination that will propel India into a new era of progress and prosperity. It is a journey that reveals the very essence of our nation's spirit, a pursuit to excellence, and our commitment to building a sustainable and thriving future progress. Now, I invite my colleague Sakshi Shinde to introduce the speakers for today's session.
The distinguished speakers for today's online interaction are Mr. A.S. Khanna, the Chairman of SSPC India, Mr. Gajanan Kulkarni, the Head of Strategic Procurement at Rajpath Infracon Private Limited, and Mr. Radhesham Goyal, the Head of Plant and Machinery at Rajpath Infracon Private Limited. Before starting the individual presentations, I request our distinguished speakers to adhere to the time limit so that all of you get equal time to share your views. Let us now welcome Mr. Professor A.S. Khanna, retired from the Indian Institute of Technology, Bombay, and currently serving as the chairman of SSPC India, dedicated to surface engineering and coatings. With a remarkable 27 years tenure as IIT Bombay, he has specialized in corrosion-related research and surface engineering. Professor Khanna has received several awards. He is a fellow of ASM International and NACE International and a life member of the Indian Institute of Metals and Society for Electrochemical Science. Furthermore, he is the fellow of Humboldt Foundation Bonn, Royal Norwegian Science and Technology, and Japan Key Center. He has conducted postdoctoral research in France, Germany, and Japan. Authored 3 books, he has organized national and international conferences. Mr. A.S. Khanna today will speak on transforming India's infrastructure, tech advancements for a sustainable future. So let's welcome Mr. Khanna.
Good afternoon, and thank you very much for inviting me to share my views and ideas on the sustainable infrastructure. Actually, the word sustainable has become so common that if you want to advise somebody, use the word sustainable, and the other person becomes very nervous or very cautious. What wrong I'm doing and what he should do so that he looks to be following sustainable methods. So going into that, what basically people mean by sustainable. So what is sustainability? In very simple words, if I have to explain somebody what is sustainability, the one of the simple thing is if you can use the available materials in the natural form as much as possible, and when you use some natural materials, see to it that they don't become distinct or they just finish by your continuous use. Depending upon the availability, your use should also be in that kind of level. Use products which can be made with lower energy, because everywhere there is a problem of energy. We want to talk about conserving energy. So if you make products, if you make construction, if you make your new equipment, machinery with less energy, that comes under sustainable construction. Use technologies which save power, reducing greenhouse gases. Now, this is a very important thing, that most of the problem which we are facing today are because of the greenhouse gases. So what we can do to reduce that so that our environment is more clean, and reducing carbon footprint, which is the outcome of technologies which reduce greenhouse, and the amount of uh, carbon you burn less, that is the saving of carbon. Now, in a very nutshell manner, we all know this thing, but to what extent we are ready to practice that? For example, use of electric vehicles in transportation. Now, this is a something in Western countries from last 10 years they are propagating. In India, at least for last 2 years, they are propagating. I purchased my electric car last year, and many people told, "Oh, don't purchase, better models will come." I think that is not an idea to take somebody's advice. But if you think that an electric car will help to make the environment better and also save your money and bring out toxic gases less in the environment, please go for that. Advancement can never get stopped. It will go on increasing. Today, if you buy one uh, machine which works, after 5 years, you will get the same machine which is much more advanced than that. Choose greener energy for your built up environment. So, this basically means that, like, for example, use of hearth, things where we used to use burn coal and other things are almost gone. Use of natural gas, use of clean methods of energy to cook at your home, or many other uses. People should use those clean environment that will help. Reduce demand of energy in the refurbished building. Now, when we say refurbished building, what does it mean? The buildings where we live. And in our day-to-day living, we use air condition continuously. We use coolers. We use heaters in winter. And we use lights, maybe 3 bulbs in the same room or things like that. Can we look into that thing and try to reduce those numbers so that you can consume less energy, and hence energy consumed less is basically the energy saved, and that is going to help you in reducing carbon footprint. Optimize energy management with data analytics. Now, this is a very serious matter. Elaborate in the next slides. I mean, use of IT and modern methods of distributing electricity in your buildings and other thing, or making smart buildings. That is the aim on which I'm going to concentrate on that. So this comes under what is known as the future infrastructure, which is called smart and sustainable. We are talking about climate change. And today, if you see, I mean, even in this summer, if you see, right from Western countries to Asia Pacific countries to even African countries, the way the hurricanes have come, the way the rain has occurred. Just 3 days before, we had a very terrific rain in the New York City, and New York City was just looking like a sea. This kind of a thing has become order of the day. Wood burning, California is a very known example. Greek, we saw this time, very big thing. Australia, just now, this kind of a thing is going on. So this climate change is basically because of the excessive use or wrong use of our day-to-day resources. So how can we cut down that and modify that? That is the first focus on which we have to look into that. The second point also say that how the bad climate comes. 30% of the world's carbon emissions are from the industrial production. As you know, power plant, textile industry, oil and gas industry, chemical industry, and so on and so forth. However, more than 40% of this thing comes from your housing, because you see big societies, number of the people living in the houses, there are simple houses to most sophisticated houses where all kinds of modern amenities are used, which consume more energy, and more energy consumption basically means distribution of bad things to the climate or making the climate slightly bad. So this idea of smart construction, which can reduce the use of electricity and natural resources or man-made resources less, is the most important and burning problem. So I was just reading one of the article in which Siemens, they are creating what is known as the smart infrastructure. Now, basically, a smart infrastructure, the word, whenever the word smart comes, it basically means how to use same kind of resources, which are either heat, which are electricity, or and make it in such a manner that the loss in the transmission is as small as possible. And here, when we talk about Siemens smart infrastructure, basically it means a smart electrification system in the buildings that helps to a greater extent to save the wastage of electricity and hence wastage of the resources. Another important problem is the that when we use heaters, when we use heating system, and so many things in the thing, part of the energy which is called energy which is not trapped. For example, when you use a air condition, at the backside of the air condition heat is coming. When we use a washing machine, backside of this thing the heat is coming. So all that heat which is untrapped one, that finally comes to the environment and it creates a big problem. We have to use solutions which already exist. Heat recovery technology exists that can use excess of the heat from industries, wastewater facilities, data centers, supermarkets, metro stations. So this untrapped energy needs to be removed and used for certain simple activities for which we use otherwise the new energy to work into that. And purest form of the energy efficiency. A global push for higher efficiency can help avoid almost 30 million barrels of oil per day. That corresponds to almost triple to the average of Russian production of 21, and around 650 BCM of natural gas per year, around 4 times what the EU used. So basically what we are saying that it is possible to enhance the efficiency so that the conversion of oil and gas to power should be much better terms. So this is one of the example of decarbonizing the building, basically, which means removing the heat and putting them a very suitable electrification. So this is an example of a office building, which in which you can see all these methods have been properly used, and which not only conserves the normal electric use, and at the same time whatever energy is trapped into the system, that is also removed in a proper fashion and used for some alternative method. This was the example of a mall in which all these steps were taken. So I'm not going into detail in that, but you can think comes, you can read it. So basically it was a supermarket in which the most modern method of electrical connections and distribution was done, and at the same time areas where the air conditions were there and the heat was coming, that was properly tapped and used for some other purposes. And the effect was that, as you see in this was a Denford smart store, is expected to be approximately 50% more energy efficient compared to a typical supermarket, with a first generation carbon dioxide refrigeration system and 20 to 30% more efficient than a store already fitted thing into that. So this is basically the smart construction. And the idea of smart construction is basically to utilize whatever energy you are taking to the maximum level, and all untrapped energies should be utilized rather than thrown to the environment. Now, I've just given you the examples of the so-called big things, but this 10 point will show you how there are a lot of other things which can also help you to reduce the energy consumption. For example, ease of using AC. You can save 20 to 35% electric bill by using solar heat reflective coatings. Now, I'm going to explain this thing from the next slide. Use of natural sources to dry laundry. It looks very silly, but then you see that today there is a fashion buy the washing machine which has a dryer also. Now the amount of energy which the drying with the washing of the cloth takes, almost 1.5 times of that takes for drying. So now it is just a slightly labor intensive, where you can remove the clothes and then dry in the natural environment, and you will save electricity on that. Wash clothes in cold water rather than going for hot water use. Use cloth napkins, rags instead of paper towels. As you know, how paper towels are made. Paper towels are made from the intensive use of trees and special kind of things, and there's a long process of making it. And most of the paper towels are one use. But if you change them to the cloth, you can wash them, reuse them several times. Switch to LED light. I think the simplest thing, which 80% of the elite people have already followed, that in their homes, 80% of the light is now LED light. And so that is being followed very much. Efficient heating management in the winter, better insulation, use of natural gas rather than the steam or hot water. Uh, Plant some trees near your house at the right spots, which gives you, one is the right environment, and also it saves up to 25% of energy. Installing rooftop solar powers, which is also increasing very much, and it is very much there in that. Create a habit of growing common vegetables, herbs in your small backyard. You know what is the use of that? Because in your fridge you keep the common vegetables for 10 days and use a lot of electricity for cooling. But if small vegetables are available in the fresh form, you can use them in much better way. So I'm just giving you, finishing my slide talk by giving examples of solar heat reflective coating, how it helps to reduce your electricity bill, and at the same time saves the carbon footprint. Now, this is just an example. A store in Vijayawada, this is the rooftop of the store, and we measure the temperature of this thing on a particular day when the outside temperature was 40 degree. The rooftop temperature was 56. After applying the solar heat reflective coating, the temperature was 44. 12-degree drop in temperature when the outside temperature was 35 to 40. The same experiment we did in Delhi. In Delhi, when the temperature outside was 35 on October 4, we did, this was a small shed which was closed from all sides, and this shed containing hydrogen gas cylinders. When we measured this temperature on the top, it was 53.5. After applying the cool roof coatings, the temperature was 33. 20-degree drop in temperature. And then the inside ceiling temperature was 46, and inside ceiling after coating it was 32. So ultimately, if you see from the table, from an outside temperature of 35 degree, by applying this coating, you reduce the temperature by 9 degree in the room. Now, can you imagine 9-degree drop in the temperature of the room will save how much of electricity for the AC? This is the crux of the whole thing on the school roof coating. Similar things were tried for concrete buildings, and in concrete building also we found a temperature drop of 15 to 18 degrees centigrade, and this is very much useful for our common day-to-day buildings. This can also be used for AC buses for railways. This is the normal railway, and next is the AC railway, where we found that there was on AC railway compartments, we found that the temperature drop of 24 degree was noticed. So this will, how much energy it will reduce, or how much for cooling in the compartment. Now you just see what is the benefit we get. If we take a small room of 1,000 square foot and use one AC of 1.5 ton for 10 hours a day, we spend around 14 units of electricity. But if you apply this coating, you simply save 7 units per day. So if you convert the 7 units into rupees, considering around 5 rupees per unit, you save 35 rupees per day. And if you convert this into the carbon footprint, we find that the best quality of the coal, 600 gram of the best quality of the coal will give you 1 unit of electricity. So 7 unit means 4.2 kg per day is saved from one AC. So if you have millions of ACs in the city or in country, you save tons and tons of carbon. And that is one of the simplest way with less expenditure, etc., to reduce the carbon footprint and hence reduce the global warming, which is the solution for tens of our day-to-day problems which we are seeing in India. Thank you very much for your kind attention.
Thank you, Mr. Khanna, for the detailed talk on transforming India's infrastructure, tech advancement for the sustainable future.